Hello, Keith Rucker here at VintageMachinery.org. So I got a project coming up soon that I need to do on the milling machine that is going to require some kind of small, delicate parts that need some milling done on them. And they're just going to be difficult to strap down to my table using regular toe clamps and what have you. So what I've decided to do is build a little mini pallet system, and this isn't anything really new. In fact, if you watch a lot of the other YouTube channels, no doubt you've seen this being used on other channels. In fact, I guess, at least for me, the first person I saw do it was Tom Lipton over at Ox Tools, and he had a little mini pallet system that he built to do exactly the kind of stuff I'm looking at doing. And I've been wanting one for a while, but now that I got this project coming up, I said, you know, it's just time to go ahead and build one. So basically what I'm going to build this out of is I've got a block of aluminum here. This is 6 inches wide, it's 1 inch thick, and I think this is about 12 inches long. I ordered this online and from a metal company. They had a deal. You know, I was wanting a piece 10 inches long, but they said, well, they'll send you a random length piece between 10 and 12 inches, and it was cheaper than the 10-inch piece. So I think this is actually about 12 inches long. So anyway, got this, and we're going to do a little machining to it to turn it into a pallet. So basically what this will be is this will be something that I can put in the vise on my milling machine. I don't have my vise here right now, but it'll go into there. It'll create a flat surface. This will be a machine flat surface. And I'll have a bunch of tapped holes in here that we can use to bolt things down to, screw things down to. And it makes for a very nice little setup piece, again, mostly for working on smaller, more delicate pieces than what I'm usually working on a big milling machine. So with that, let's get started on doing the machining work to build this little mini pallet. So first off, let's just talk about plan of attack, what we're going to do here, and what we need to do. So again, this piece is about 6 inches wide. I know that my vise opens up to about a 4-inch width, just a tad over a 4. So it's a little bit too wide to actually set down in the vise right now. So what I'm going to do is just mill out some steps on either side. And I'll have a 4-inch wide strip here. I'll go half the thickness, so 1/2 inch. So basically be a 1 inch wide by 1/2 inch deep slot milled on either side. This is going to be the bottom of the pallet here that I'm working on. And once we get this side done, we will actually put the vise on the mill machine, flip it over, put this in the vise. We'll surface the top of it, which will be the other side. So we'll put a shell mill or a face mill in here and do that. And then we'll come in here and drill and tap the holes that we'll use for clamp down. So I've got my vise off the mill table right now. We're going to actually bolt this down to the table, clamp it down using some toe clamps, and get in here and mill it out. So let's get that done. So just a little bit about using a toe clamp in this situation. You know, I'm going to actually do these a little bit of an angle, just so that I have I'm not right over that slot, and it's going to be fine for what I'm doing. But when you do these on a flat surface like that, you really don't want this to clamp down flat. You want to have just a little bit of an angle, but not much. So what I'll do is I will usually just bring it in here, and once it butts up against that, I'll just pick it up to the first notch that it comes to, and that'll be the one that I clamp into. And we'll drop stud down in there, and let me grab a nut. And right now I'm just going to snug it. I don't want to tighten it down yet because I want to make sure that this is running square with the table. Let's get the other side done. Alright, so I've just kind of lined this up on this front edge here, and moved a little bit. But you know, to get it started, I'm just going to work off of a known surface, and now what I'm going to do is get my indicator, and we'll indicate off of the front of the back here to make sure this is lined up parallel with the table. To trim this piece in, I've got my stare at last word indicator, and this seems to be my little go-to indicator for doing trimming in a vise or anything like this on the mill machine. Accurate to 1/2 thousandth, which is plenty good enough. So I just got it up there. I'm just going to move the table to zero that out. And what we'll do is we'll just sweep it across the front and see how it moves. So as you see, it's dropping off a little bit. That piece of metal may not be perfectly flat across the front, and that's fine. So, we get to the other end here, and, it's about 5/1000ths out. So what we're going to do now is I'm just going to bump this back to 0, which is what we started with on the other side. And now I'm going to sweep back across and see where we're at on the other end. Guys, again, this is a piece of extruded aluminum. It's not machined, so this should be fairly flat, but you can see there's some irregularities in the surface. We're at 0 at either end. Yeah, it dropped down, 0.5 to 1,000, somewhere in the middle. No big deal. That's good enough. I'm going to go ahead and tighten up the clamps on this, and we'll be ready to start milling. For this milling, what I'm going to be using is this high-speed steel end mill, and this is a Niagara cutter end mill. This is one of the ones that Dennis Nolan up at Niagara Seco sent down to me to try out. And so this one's high-speed steel, 3/4 inch in diameter. I'm going to be making a 1-inch wide cut. I would love to just use a 1-inch wide end mill, but unfortunately I don't have a 1-inch end mill that's shanked down. My collets will, I think, will only go up to 7/8. If I remember right. So I've got 1-inch end mills, but they're all 1-inch shanks, so they won't really work in this setup without having a different type of adapter. So I'm going to use a 3/4. This one is a 4-flute. On this aluminum, a 2-flute would probably be a little bit better option, but again, I'm going with what I've got. So we're going to give this a try. Game plan again. It's going to take 2 passes. Just because I can't do the whole width, so we'll probably do a 1/2 inch and a 1/2 inch. And depth, I'll probably again do it 2 passes. We're going a total of a 1/2 inch. So we'll go 1/4 inch deep on each pass. And I think in this aluminum that'll cut just fine. So let's get in here and do it. So first thing I want to do is I want to come in here and do some zero. And then, these measurements are not super critical. We're not going to tight tolerances. We just need to create a groove in here. Really, the only thing that's critical is that the bottom of this groove be the same on both sides, and that we have enough room in here to grip with the vise. So what I'm going to do is we're going to go ahead and turn the mill on. I'm running at about 500 RPMs, and I'm just going to come in here and raise my table up until I see it touch off. And yeah, we'll call that touching right there. It's not all the way around. Again, this is an extruded surface, so it's not perfectly flat. But what I'm going to do is come over here to my digital readout now, and I'm going to zero the Z-axis. And next thing I want to do is come in here and again, using my digital readout, I'm going to go up 250 thousandths. Right there. Again, I'm not really critical on there, so I'm not worried about the 2/10. And I'm going to come in now and touch off again, this time on the Y-axis. And right there is close enough. So I'll zero that. Roll my table out to the end here. Yeah, it's touching there, but again, it's not critical, guys. In fact, I want this to be a little less than 4 inches wide. So let's go a little bit more. Now I'm going to come in a 1/2 inch, so 500 thousandths is going to be our cut. Not critical, but we'll get as close as we can. I'm going to lock my table down and using the auto feed now. We're just going to plow through this. Some nice chip coming off of there. I'm going to go back to the other side here, and I like cutting in this direction. The feed is going into the cut. It just works a little bit better that way. So we're going to make all our cuts in that direction. And I'm going to take this to a 1 inch. And we'll feed it again. Now I want to come back in to 1/2 inch on my digital readout. Close enough. And we're going to raise the table up to a 1/2 inch. Right there. And feed through it again. Now for the final pass on this side, we'll bring it back into 1 inch on the total depth of that cut. Another 1/2 inch actual cut. Right there. Let's cut it. We've got one side done. Let's get in here and clean this up. I'm pretty happy with the way that looks. I don't know, we got a little bit of, I might just take a real light pass on that back side because it looks like they just pulled some chips in there. I don't think that it's actually a bad surface. It's just got some chips kind of pressed on there, but we may just skim that back across with a couple thousandths to clean it up. But then we're going to flip it, or not flip it around. We're just going to go to the other side and do it. And I'm going to do the other side off camera. Exact same process. It's going to be on the back side. It's going to be hard to see, but we want to get this exact same setup on the back side. So we've got our slot milled in the bottom of this now so that it will fit down in the vise. I went in here with a file and deburred all this so there's no sharp edges or anything. So now this is going to just sit down in the vise. We'll tighten the vise up. And I'm going to kind of tap that down, make sure we're good and flat. Excuse me. And the next thing I want to do here is surface this and get a nice good flat surface on here. We could leave that like it is, but chances are, again, this is not a machine surface. This is a just an extruded piece of aluminum, so we want to get that perfectly flat. So I'm not wanting to take a whole lot off, just kind of fuzz it, take a couple thousandths, just whatever it takes to clean it up. And the nice thing about this setup is that as you use this, you know, if you mill down into this, you know, a little bit when you're working, or if you scratch it up, no problem. You just face it off, take a few thousandths, fuzz it off, and you got a nice, good, clean surface to go. So I've got this face mill in here. This is the one that Dakota Hunt sent to me a while back. You know, this is made where you can put inserts all the way up for good side milling. I'm really just using it as a face mill. You know, I really kind of wish I had one that was a little bit shorter than this, but it works great. This is an excellent piece of tooling, or it has been. So we're gonna let it go, or give it a shot here. So again, running about 500 RPMs. I'm gonna come in here and I'm gonna raise my table up until I'm just touching it. Back it off, and we'll just power feed across that. Looks like we've quit cutting here, so we're going to go ahead and just take it like it is, and then we'll come back and fill it in. This is why I want to mill this on the part itself, so that I can get it running flat on this vise. And as you see, it's got a little bit of a taper into it. It's probably my vise has a little bit, or it may have a saddle. So yeah, it looks like it's picking back up over here. So that piece of aluminum may have a little bit of a dish in it. It's what it's looking like now. To the point now where we're ready to start putting the holes in here and drilling and tapping our holes. And I want to lay this thing out in a grid pattern, but instead of my holes being in a square, I want to be more in a diamond shape. And I have kind of gone back and forth about how I want to do this. And I can use my digital readout, and it has a function. It's actually a grid function. And what I was really wanting to do was set up my grid on a 1-inch square, rotate it 45 degrees so that I had that diamond shape, and then just let it navigate me to every hole. And it has the ability to rotate a grid 90 degrees. The problem is that when it does that, it works off of one corner and it rotates off. So, you know, it will lay a grid at an angle, but it's not going to give you all the holes that you need. In fact, let me zoom you in here and I'll show you what I'm talking about on the picture here. So here's my manual on the digital readout, and this is the grid function. And again, you can set a grid up. You can set up whatever distance. It doesn't have to be a perfect square. It can be rectangles. It can be whatever, as long as you're at the same increment on your X and Y axis. And then you can rotate that grid. But when you do, it rotates off of a single point. And in my case, I'm wanting to put more holes, down here. And it's just not going to be practical to do it. Yeah, I can make my grid bigger than I wanted to and start it on an imaginary area and cover my table. But the problem is that it's going to navigate me to each one of those holes, and I have to drill them in order. So I'd be basically having to navigate to a bunch of points that there wouldn't be a hole at. So to get around it, what I'm going to do is I'm actually going to, well, let me get my drawing and I'll show you. So this is a sketch of what I'm after, and this is not to scale. This is just something I drew up to try to figure out my placements and all that. But again, I'm more in a diamond shape here, so I've rotated that grid, and these should be perfect squares. Again, this is not to scale, but it illustrates the point. So to get around this, what I'm going to do is we're actually going to use the grid function, letting it go flat, but I'm going to actually make two different grids. So if you look, we got one square pattern here, and then there's another square pattern here. So we'll start on this point here. We'll drill out the ones that are in a square pattern. We'll go through, drill all those holes, and then basically I'm going to come back, start me with another beginning point, which will be this hole, and I will lay another grid out that will have the same XY coordinates, but we'll just start in the center, and we'll go through the whole process twice. That's the plan. I think it'll be fairly straightforward. I've never used this grid function before. I have played around with it, but I've used some similar functions on my DRO, and I think it'll work just fine. So with that, let's get the DRO, the digital readout, set up for the grid function, and we'll go through those processes, and then you guys can see us navigate through here and start drilling and tapping some holes. So the first step in setting this grid function up on my DRO is I need to get over my first point, 0, 0. I want my 0, 0 on my digital readout to be over the first hole. And I did this off camera, but I'll just kind of show you what to do. We went in with our edge finder, found the edges on these two corners, made 0, 0 this edge right here, and then I navigated to my measurements that I had already calculated I wanted that first hole to be, which was, this was 0.575, and this is 0.525 in this direction. And I did that again. That was part of what I did when I sketched everything out, is I figured out trying to get my hole pattern, I won't say perfectly centered on here, but basically where my holes will be in useful places. And I just had to get on a piece of paper and figure that out. But anyway, that's where I'm going to start, and so that's right here, and we're on 0, 0 on our digital readout. Let me switch over to the digital readout and show you the process of setting this up. So again, I've already zeroed my X and Y to that starting point. And what I want to do is, this is a digital readout made by DRO Pros, DRO Pros. Had this for several years, love this DRO. Highly recommend them if you're looking for a DRO for a mill or a lathe. But I'm going to use the grid function, which is this button right here. And it tells me in my instructions here exactly what I want to do. So it's telling me to enter the center 0, which is basically my X and Y coordinates I'm at now. I'm at my 0, so I'm just going to hit enter. Enter center 1, enter. So I've got my 0, 0. I'm telling it, okay, the 0, 0 I'm at is where I want to start. Now it's asking me for my pitch in my X and Y direction. This is the X. And the pitch is the distance between the holes. And let me grab my cheat sheet here. The distance between my holes is going to be 1.414. And what that is I basically, I want them to be on a 1-inch grid, So I calculated on a 1 inch, if you take a right triangle, isosceles triangle with 1 inch legs, what's the distance of the hypotenuse across that? And it's 1.414. So I'm going to hit enter for that. It's going to ask me my pitch for my Y. Again, it doesn't have to be a square, it can be a rectangle, but I want that same number in there again. So 1.4114, there we go, enter. And then it's going to ask you for the angle, and again I showed you could rotate that, but we want to leave it at 0, so I'm just going to hit enter. And it's going to ask you the number of holes and the X and Y direction that you want to do. And let's see, we want to go in the X axis here, we want to have 8 holes, so put in 8, and in the Y axis we want to have 4 holes. All right, so now basically this thing jumps to a different mode, and we're at 0, 0. That's the location for our first hole, so we will drill that one, and then we will basically step to the next one, and it will navigate us to the next hole where we don't have to do any math, and we'll show you that process here in a minute. All right, so first off, let me just make a comment here. I'm using this new keyless drill chuck. This is a Jacobs chuck. Got it from the lot of tool and die maker tools that I got from Lou Cousins. So anyway, I'm excited to give this a try. It's the first time I've really been on the mill here, so we'll be using that throughout. But I've got a number 25 drill bit in here. That's the drill size for tapping a 1024 hole. So we're going to be using this throughout, and we'll go ahead and drill, countersink, and then tap these holes as we go along. So we're on our first hole, so let's fire up the mill here, and just go ahead and drill this first hole. Okay, I'm going to swap this out, put a countersink in here. Swap it out again, put in a tap. I'm going to slow that down for tapping. I'm going to put a little Alumitap in here, Tap Magic aluminum, and first hole done. So now get over here to the digital readout, and what we'll do is we will navigate to the second hole. So basically I'm on the first hole, go to the next one, I just hit the 6 button, I go forward a hole and back a hole just using these 2 arrow buttons here. So basically it's telling me there again I need to move over 1.41 inches. So I come in here and we will just take that to 0 on the digital readout. A little bit too far. Hopefully I'm not in your way. I'm trying to, it's real tricky to get it right on 0, 0. There we go. And I lock my table down. And we are in position now to drill the second hole. Put my drill bit back in. just like before, we'll go to our next hole. Right there. So over here now, I've got a couple of holes that my tap is going to be right over the vise, and I don't want to go too deep. So what I'm doing is I'm just going to take a piece of tape and wrap around this tap. Tell you what, let me make my piece of tape smaller. Do that again. So I'm looking at my depth. I put my finger right there, and I'm just going to put this on here as a marker showing the depth I can go before I hit. So I look there, I go down, and when I hit the tape, I'm basically not through, but I'm right there at the bottom, and I can come back out. So, and what I'll do is after I get through, we'll go back and hand tap those so they go all the way through, but we want to at least go ahead and get them started. So let's go ahead. I'm going to probably slow that down just a little bit too, just to make sure I can react in plenty of time here. There's the depth. Whoops. Tighten that back up. There it comes. All right, like I said, we'll go back and do those later. All right, you see the process here. I'm not going to bore you guys to death. Going through every one of these, we'll go through and finish this grid and bring you back when we start the next one. We've got all of our first set of holes drilled on the first grid, drilled and tapped. Everything looks good, and I am back over my 0, 0. As you can see on my digital readout, we're out of the drill or the grid mode now and just back in regular coordinates. So basically what I need to do now is repeat this whole process, but I need to position my new grid kind of in the center of this one. So I know from my measurements that to get there, I need to move over 707 thousandths in both the X and Y axis. So I'll just come in here to the digital readout now, and we'll dial that in. $707. Right there, and you come in on the X or the Y and do the same thing. Lock my table down. Right there. Okay, so now I'm going to re-zero both of those on that axis, and we will go in here and do the grid function again. So let's see, we'll hit grid. We want these, we're on 0, 0, so enter, enter. That's just telling me again that I have my 0, 0 there. My pitch again is going to be 1.414. So we go 1.414, enter, 1.414, enter. My angle is going to be 0 again. Number of holes, just like before. In the Y, or excuse me, the X, we got 8. And in the Y, we have 4. And telling me I'm right on my first coordinates there. To drill this one in, go through this process again. So when I flip this thing over, I realize I got a bunch of rough holes here in the bottom where that drill punched through. So I'm going to take a few minutes and just go through here, and we're going to deburr all these. And I'm going to take them probably a little bit deep just to make sure to get those burrs out of there. Here we are with the finished pallet part of this project. So we've got all of our holes drilled and tapped. Again, these are on a 1-inch grid at a 45-degree angle. And that's exactly what I wanted. That should give me good selection of holes that I can tap into to clamp things down with. And we got the bottom all deburred now. Need to blow it out. It looks like there's a few chips stuck in there still. But this part is done. Next step is we need to work on making some of the hold down clamps. And those are basically miniature versions of, this type of a hold down clamp like you'd use on a mill, but it will be scaled down to use on something small like this. And we'll do that in another video at another time. Well, that'll be a wrap, guys, on this part. We'll come back, like I said, and do a follow-up video making the rest of the hold down pieces at another time, but this is going to be good for today. Always fun, 64 holes to drill, countersink, and tap, and maneuver to each one precisionally. It took a couple of hours to do all that, but we got it done, and this will be a nice little addition to the shop that will come in handy for lots of things. And like I said, I've got a project coming up pretty quick that we're going to use this on, so that's the reason for getting this done right now. Thanks for watching, and as always, appreciate your comments, appreciate your thumbs up or your likes on the channel here or on the video. If you haven't already, please subscribe to the channel. Always have new stuff coming down the line that hopefully you'll enjoy watching, and we'll talk to you guys at the next time. Thanks.